All right, guys, so this is a follow-up video to the last problem that we started in class, or ended on in class right at the end there, which I couldn't figure out what that solution was, what's getting us to the very last step there. So this is exercise 5F number 7, where we're trying to show that this b squared has to be less than or equal to 15ac. So in class, if you recall, this was the function that we were given. We were asked to find its derivative, so we did that just using our power rule idea. And then part B was where it got real. So it said, show that b squared is less than or equal to 15ac, given that the derivative function f prime is greater than or equal to 0 always, and also with this knowledge that a is positive. So in class, we were able to get this far. We had really good thoughts about, well, we have to maybe try using quadratic formula, because at least I can see this b squared minus 15ac pops out. And then I couldn't quite get us to that place where it had to be true that b squared minus 15ac was essentially less than or equal to 0. Okay, so I was playing on Desmos, looking through a bunch of different tools, trying to understand this function a little bit better, and here's what I came up with. So the whole key to this problem comes back to that statement right here, that f prime of x has to be greater than or equal to 0. So let's come back and talk about f prime super quick. Take a look at f prime sitting right here. It's the shape of a quadratic equation. So it's an x squared function, right? So it's a quadratic, it must be a parabola. Because a is also positive, is strictly positive, that means that this first term here, 15a, is positive. I know that when leading coefficients are positive, the parabola opens up. Okay, so now I'm going to draw a couple of cases. What could our parabola look like? Remember, it's key that f prime is either always positive or equal to 0. So case number 1, if f prime of x is always greater than or equal to 0, then one of the possible options that it could appear as is the parabola something like this. So if you're looking carefully, you'll notice that at no point is this parabola in the negative area down here. There is no time where the function goes into the negative regions. There is a single point, however, that is equal to 0. It's the vertex of my parabola f prime. So when the vertex is equal to 0, there's this little rule here that the discriminant is equal to 0. You're basically saying in the quadratic formula, in order for this to have only one x-intercept, this thing has to be 0. The discriminant, b squared minus 15ac, has to be equal to 0. Because then that would get rid of that part of the equation, and the 4b over 30a is your vertex, and it winds up being your one and only x-intercept. So that's a lot of stuff from like integrated 2 and pre-calculus. That might be a little bit fuzzy, but hopefully it's coming back. Okay, so essentially what we get is that the discriminant would be equal to 0 in this case. I have exactly one x-intercept. It is the vertex. That means the discriminant is equal to 0. And in our case, the discriminant is b squared minus 15ac. If I set that equal to 0 or add this to the other side, I get that b squared must be equal to 15ac. So that's case number 1. Let's look at the other possibility, case number 2. And again, just to reiterate, I'm building my cases off of the fact that f prime of x is always positive. So parabolas could look like this if they're positive or equal to 0. The other option is that they might just be living totally up here in positive land. So they're not hitting 0 at all, and they're not going negative. So it might look something like this. All right. In that situation, notice how there are no x-intercepts at all. So I'm trying to say here that my f prime of x in this situation is always positive like that. Now, if you remember, what happened when you couldn't find x-intercepts? One, you couldn't factor the quadratic, and so you had no maybe x-intercepts. The other option was after you tried with the quadratic formula, you'd get a negative under the square root, right? You get something that was negative here, causing you to have imaginary numbers or complex numbers, and ultimately that meant your parabola never crossed zero. So the other option you might have here in this situation is that your discriminant underneath the radical was less than zero. It was negative. In our situation, that looks something like b squared minus 15ac would be negative. And when I add this to the other side, I find that b squared is less than 15ac. So now I can tell that regardless of which case I'm talking about, if I put these two results together, it has to be true always that either b squared is less than 15ac or b squared is equal to 15ac, and that draws the final conclusion that ultimately b squared must always be less than or equal to 15ac. So major key points here, it really matters that a was positive. The parabola opens up. The other thing that really mattered was that f prime, our derivative function, which is a parabola, had to be positive or equal to zero. And so what that led us into was these two cases. If it's equal to zero and positive, it might look like this, in which case the discriminant is zero and I get that result. Case number two, maybe your parabola is only positive and not equal to zero, in which case no x-intercepts, your discriminant is negative, and that led us to this result. Together, we find out that b squared must always be less than or equal to 15ac.